Okay, so we were going to show you a bit about the geometry validator because there's been a huge amount of work done on this transformer in FME 2013. And this is a transformer that's very useful when you're writing geometry to a database because SQL Server in particular is quite happy to let us write anything into the database in terms of geometry, but the problem is we get it in there and the SQL Server itself doesn't like it. So it's a good idea to pass your features through the geometry validator first and see if it can repair them or fix them up at all. And so the new geometry validator has got a set of 12 tests available for you, and many of these tests actually will repair the features. So there's a repairable option on there that says, yes, fix up my 2D, my intersections in 2D, for example. There's also 2 tests there that are just testing to see whether your features are OGC simple or OGC valid. So those 2 tests actually don't allow for repairs, but most of the rest of the tests do. There's a button at the bottom to say, do you want to attempt the repair? And you can set that to yes or no. Consequently, the transformer's got 3 outputs, and so output will come out of the passed port, the failed port, or the repaired port. And it's very important to pick up data out of that repaired port when you're working with it, because that is your fixed data. And sometimes features are just unable to be fixed, so they will always come out of the failed port. Similarly, if you're testing for these OGC tests, these will always come out of the failed port. So in my example here, I was going to load up a shapefile of world boundaries. So if we go and take a look at the data, have you got a data inspector here? I can drag them into my data inspector and take a look at them. So this is an AIR3 shapefile of data from all around the world. And you know, you can sort of guess, what countries are we going to have problems with? Russia, which you'll notice goes right from one end of the display to the other, and Antarctica. So there are a couple that could cause us some grief when we try and write these into our SQL Server spatial. And in fact, in this case, and it took me a long time to figure this out, Antarctica is in so much trouble here that it actually has a minimum value that's below -90, which is means that it's fallen off the bottom of the world. So in my particular workspace, Antarctica will never get into my database because of that minimum value there. So I should have put a clipper in here to clip it before I tried to load it. What I did instead was found a cleaner set of data that's here, which I've included for when you get these workspaces, you can try this stuff out.
And that is using your Zipster.
Actually, let's go play with that. So this is opening, this one is using a zip file. So I didn't bother to unpack it. So if we go back to our data inspector and take a look at it, I can drag that zip file into here, and I just have to tell it actually what format it is because it can't guess from the extension. But it's going to read the data right out of the zip file without me having to unzip it, which it does. And if we take a look at Antarctica in this particular example, you can see that those minimum values have been fixed. So this one would have gone in for me, but I preferred to play with the bad data. So as I processed this data, I had to, you know, it's complex data. It's got a lot of those countries have got incredible, if we go back to my data here and take a look at, say, Denmark up here, which is right here, and we go really far in, we've got some interesting overlapping stuff happening here. So we know that we're going to have an issue with our data because it's just not good enough quality. We'll certainly be able to read it into or write it into SQL Server, but SQL Server is going to complain once we've got it in there. So what I had to do was pass that data through some geometry validators to get it to be cleaned up. So I passed it through the first geometry validator, looking to do things with those self-intersections. And of course, once I've done one cleanup of it, and it's repaired a number of features, it may have actually created new self-intersections. And so I ended up having to run it through 2 of them to try and get the best output that I possibly could. And so if we take a look at this and run this workspace, you can see by the feature numbers. I just want to check that we're dropping the tables. Yep. And in fact, what I did here was I ran it through to 2 tables. One's the geometry table, using the geometry spatial type, and then the other one was the geography spatial type. So here I'm letting it inherit that spatial type from the writer because the writer was set up by default to use the geography spatial type. And we can see that over here in the navigator pane. So one table is going to have geography spatial type with a geog column, and the other one will be a geometry spatial type. So let me run my workspace and we'll take a look at what happens. So I still have some countries that have got some problems, and interestingly enough, they turn out to be Italy and Norway and Indonesia and New Zealand. It's hard to believe New Zealand could have problems with its boundaries. But you'll notice how 54 features came out of that repaired port, and once I validated them again, it still repaired another 4 features. So if I go and take a look at my SQL Server in here, and I have a command that I can issue that asks whether or not that geometry has gone in and is it valid. And so when I do that, I can execute my statement. Oh, and we forgot to fix these table names up. So let's just, in the interest of time, we'll presume that it found a bunch of bad data. And in fact, if this new geog is valid detailed, will give you the message showing you what the error number was and the cause of the error. So you get some more information from within SQL Server as to why your geometry is bad. And so how to fix that automatically within our workspace, the last thing that we can do is actually use a SQL statement to execute after the translation's complete that allows us to update those things. So we can put our statements in here to fix that geometry by using the make valid function or process. Not being a SQL person, I don't know what the right word is, to clean up our data. And so running this workspace again would run this through correctly and fix our geometry in our tables. So it's just worth looking at the data, checking that it's okay, because we are very happy to write anything into your database, and the geometry validator will help clean your data up for you.
And I think we are planning to add the SQL Server is valid functionality into the geometry validator in the next round of development there.
Excellent, because yeah, so it will become.
So our goal is eventually you can choose which kind of validation options you want to check off here. You can do that manually or not. And our goal is to add a list of databases here. So validate for SQL Server, validate for Geodatabase, validate for Oracle would be nice to have.